So this video is going to help you with the graphing an exponential function and finding its domain and range. So the graphing of exponential functions will be optional for you, but I did want to give you some tools in case you decide to complete those. So let's start with what an exponential function is. We'll be discussing this a little bit in class, but I just want you to know what an exponential function looks like for when we get to graphing it. So an exponential function has the form f of x equals a times b to the x, where a can be any real number it wants. So a is any real number. B is the base of the exponential function. And b must be a positive real number. That's not 1. So the base of an exponential can't be 1. That's because if this base were 1, 1 to any power is 1. So if your base is 1, then that function has different functions than any other exponential. So we kind of put that in its own category. We remove it from an exponential function because it acts differently than exponentials. So your base can be any positive real number that's not 1. The base also can't be negative because if your base is negative, when you raise it to different powers, sometimes you get positive numbers, sometimes you get negative numbers when you take a negative number to a power, and that makes your graph do funny things. And again, it doesn't act the way that exponential functions act. And so b has to be positive, can't be 1. And then x is the exponent of the function. Notice that the exponent of this function is where your variable is. That's what makes an exponential function. An exponential function is that your variable is in the exponent. We're not going to bother with the natural number e in this video. We'll do that in class, but for now, this is what an exponential function looks like. And our goal today is going to be to graph these guys. So what if I wanted to graph f of x equals 2 to the x? This is an exponential function. My base is 2, and I have an x in the exponent. My variable is up there in the exponent. So in order to graph these, I picked some x values for you, and we're going to plug them in and see what y is. So if x is negative 2, then my y value is going to be 2 to the x power, and x is negative 2 here. 2 to the negative 2 power. Recall that a negative exponent gives you a reciprocal. If you have a negative in the exponent, it basically means you can't stay here, you're being evicted, you got to move. Right now, 2 to the negative 2 is on the top, right? There's an over 1 kind of understood here. So 2 has to move downstairs. When it moves downstairs, the exponent becomes positive and it leaves a 1 behind. And then so 2 to the negative 2 is 1 over 2 to the second power. That is 1/4. All right. How about if x is negative 1? Then our y value is going to be 2 to the negative 1 power. Again, a negative exponent says, you can't stay here, you have to move. 2 to the negative 1, that's got to move downstairs since it's upstairs already. When it moves downstairs, the exponent stays positive and it leaves behind a 1. And so 2 to the negative 1 is 1 over 2 to the positive 1 power, which is 1/2. When x is 0, y is going to be 2 to the 0 power. Recall anything to the 0 power is 1. 1. There's an exponent rules video that I have already posted. That'll walk you through why anything to the 0 power is 1. But for now, just know anything to the 0 power is 1. And what if x is 1? Then y is 2 to the first power, which is 2. And if if x is 2, then y is 2 to the second power, which is 4. All right, so we've got some ordered pairs here. When x is -2, y is 1/4. So we've got the ordered pair -2. Let's eyeball 1/4 here. Then the next ordered pair is x equals -1, y equals 1/2. Again, I'm just going to eyeball that one. X equals 0, y is 1. Ordered pair 0, 1. When x is 1, y is 2. And when x is 2, y is 4. So these are our points. We're going to connect these with a nice smooth line, and these are actually going to continue on forever. And notice when we connect these, this is going to approach the x-axis over here, and there's actually an understood, there is an understood asymptote right here at y equals 0. This has a horizontal asymptote here. All right, so this is what y equals 2 to the x looks like. Now let's do the domain and range of this function. The domain of this is the x values that it covers. This continues on forever to the left. That means the x values are covered all the way down to -infinity. And this continues up and over forever, which means it's going to continue moving to the right and covering things. So eventually 3 is going to be covered, and then 4 is going to be covered, and then eventually 5 is going to be covered. It's going to keep on going, and it's going to keep covering x values. It's going to take a very, very long time, but this is going to cover x values all the way up to infinity. So our domain here is -infinity to infinity. Now our range, again, this continues upward forever, which means our y values are covered all the way up to +infinity. And then this is going to come down and it approaches y equals 0, but it never actually gets there. So 0 is where this thing stops. We don't have any part of our graph below 0. And again, y equals 0 is a horizontal asymptote. It's never going to get there, never going to touch it. And so we're going to make that 0 open. It's got to be a parenthesis and not a bracket over here. So that's our domain and range for y equals 2 to the x. Okay, how about y equals 1/2 to the x? What's different about this one? Well, let's figure it out by plugging in some x values and seeing what our graph looks like. So if x is -2, I'm going to have 1/2 to the -2 power. Because there's just division in here, we can distribute that -2 exponent to everything inside. You can do that across multiplication and division, not addition and subtraction. Addition and subtraction ruin everything. But we just have division here, so we're good. Oops, and these both get a -2 exponent. Again, anything with a negative exponent that says, hey, you can't stay here, you have to move. The 1 to the -2, that has to move. That goes downstairs, and when it does, its exponent becomes positive. 2 to the -2, that also has a negative exponent. It can't stay here. It's got to move. It's already downstairs. It's got to move upstairs. So what we have here is 2 to the second power over 1 to the second power. That is 4 over 1, or just 4. All right, what if x is -1? We'll have 1/2 to the -1 power. Again, we only have division inside, so we can give everything that exponent of -1. We got some negative exponents, so we play should we stay or should we go. The 1 to the -1 has to move downstairs, and the 2 to the -1 has to move upstairs. And what we're left with is 2 over 1, or just 2. All right, what if x is 0? then y is 1/2 to the 0 power, which is 1, because anything to the 0 power is 1. If x is 1, then y is 1/2 to the 1 power, which is 1/2. And if x is 2, then y is 1/2 to the 2nd power. Again, you can give everything inside that exponent of 2. 1 to the 2nd power is 1. 2 to the 2nd power on the bottom is 4. So I've got 1/4 here. Now we can put our ordered pairs on our graph. When x is -2, y is 4. So come over here to -2, 4. When x is -1, y is 2. When x is 0, y is 1. When x is 1, y is 1/2. So I'm just going to eyeball that. And when x is 2, y is 1/4. Again, just eyeballing that. So now you can see this has a similar shape, but it's just backwards. Let's try to connect my dots here and make those nice smooth lines. And so we have that same curved shape, and it goes down this time from left to right. And again, just like last time, we have a horizontal asymptote right here. This function approaches that horizontal asymptote just on the right-hand side, whereas before we approached it on the left. Exponentials are interesting in the fact that they only approach their horizontal asymptote on one side of the graph. That does happen occasionally, but not on very many functions. Usually if you've got a horizontal asymptote, you approach it on both sides. Exponentials don't do that. Okay, so what's the domain of this graph? What x values are covered? Well, again, this thing goes forever. It's going to slowly cover all of the x values down to -infinity. So our domain goes from -infinity all the way up to, this goes forever as well, so it goes all the way up to infinity. And our range here, the y values that are covered, again, this goes up forever. So our y values are covered all the way up to infinity. And this goes all the way down to y equals 0, but never actually touches it. So we're going to be open again, and we've got nothing below 0. So that's our range. Okay, so if we have a graph like b to the x power, which is what we've been graphing, it's just been our base to the x power, there's no number in front. That's both of these graphs. So we're going to kind of figure out what they have in common and how to tell what this graph is going to do. Notice the domain for both of these and the range for both of these is exactly the same. If you have a base to a power, your domain is going to be -infinity to infinity, and your range is going to be 0 to infinity. And again, that's assuming that this is in fact an exponential function, and that means your base, your b value, is a positive number that's not 1. These both have a horizontal asymptote, and they actually have the same horizontal asymptote. What's the equation of that horizontal line that's an asymptote for both of these equations? That's right, it is y equals 0. And if b is greater than 1, if our base is bigger than 1, like we were here, notice this thing increases from left to right. That's always going to happen when your base is greater than 1. I'll say your graph increases left to right. Sorry, I'll make that a little more clear. Then your graph increases from left to right. And we call that exponential growth. When you increase from left to right. If your b value is between 0 and 1, if it's a fraction, like we were down here, what's different about this one? Well, this one decreases, right, from left to right. It goes down as we trace it from left to right. And so that happens anytime your base is a fraction between 0 and 1. So our graph is going to decrease from left to right, and we call this exponential decay. Exponential. Let me see if I can spell that. Decay. Sorry. Okay. So those are our basic graphs of exponential functions. Now, we have some previous programming and some previous knowledge, so we already know what transformations do, and so we'll have a little bit of transforming that we can do with these guys. Now, our basic function is f of x equals b to the x. The transformations that we'll be looking at look like this. F of x equals, it it could be a plus out here, or it could be a minus out front. And then it's going to be your base time to the x minus h power. And then you have a plus k here on the outside. Now the h and the k and this plus or minus, we already know what these guys are going to do. Let's start with this plus k out here. Anytime we add or subtract a number kind of to the outside of our function, that's going to shift us vertically up and down. That's going to be consistent with what we've done so far. If k is positive, if you add a number to the end, then that shifts your graph up k units. And if you have minus k, if you subtract a number on the end, that shifts your graph down k units. That's going to be consistent with what we've done before. It's going to move the way that you think it will. If you add, it's going to move up. If you subtract, it's going to move down. One thing I want to note here while we're here is when you shift this graph up and down, so if we come back up here to one of these graphs, let's just go to 2 to the x. If I take this whole graph and shift it up vertically, let's say we shift it up vertically 2 units, the horizontal asymptote will move up and down with the graph. So that's just something that I want to make a note of here, is that your horizontal asymptote shifts up and down with your graph. So for instance, up here, when I did the y equals 2 to the x, if I wanted to graph y equals 2 to the x plus 2, the whole graph would move up 2 units. This horizontal asymptote would also move up 2 units, up to y equals 2. So the horizontal asymptote is going to move up and down with your graph. Hopefully that makes sense. I just wanted to make a note of that. That's going to be helpful. What if we add or subtract numbers up here with x? This is just like adding or subtracting inside the function with x. And this is going to shift us horizontally left and right. And if we are adding or subtracting inside with x, it's going to go the opposite way you think it will. So if you have a minus h, if you subtract from that x inside, it's going to shift your graph to the right h units. It'll go the opposite way you think it will. So if you subtract h units, you'll go to the right. And if you add h units, it will shift the graph left by h units. Okay. And then last but not least, what about this plus and minus out front here? If it's a plus, that doesn't change anything, because technically right here, there's also b to the x is positive b to the x. It's kind of understood to be positive. The negative here, really what I mean by that plus or minus, is if you have a negative out front, then what that's going to do is it's going to give you a vertical reflection up and down across the x-axis. So it's going to reflect you vertically up and down. So if you're above the x-axis, it's going to flip upside down and go below the x-axis. If it's below the x-axis, it's going to flip upside down to be above the x-axis. Okay, so this is going to be consistent with what we already know about transformations. Okay, so let's start with this one. So this just wants us to list the transformations. Okay, here we go. Sorry, guys. All right, so list the transformations that would need to be performed. Again, this is to transform our base function. And I guess before we do this, because it wants us to list it in the order they would be performed, let's remember what order we need to perform these guys in. So I'll say note order matters. The order that you need to do these guys in, the first thing that you're going to do is shift left and right. You'll move left and right, any horizontal shifting that you have. The second thing that you're going to do is any reflections that you have. If you have to flip this thing upside down, after you move left and right is the time to do it. And the very last thing that you are going to do is your vertical shifting, where you shift this thing up and down. That's going to be your last step. Horizontal shifting first, vertical shifting last. Okay, so with that in mind, let's figure out how to do this. So our function here, f of x equals 3 to the x plus 2 power. Now, our base function here, which is the one that we would graph first and we would be transforming, is y equals 3 to the x. Our base here is bigger than 1, so we're going to look something like this. We're going to increase from left to right. We're going to have an exponential growth graph here. So this is our base graph, and what kind of transformations are we going to have to do to that graph? What transformations appear here? Well, it's this plus 2 here. This is the only transformation that I see. And what is that transformation going to do for us? It is going to shift us to the left 2 units. And that's the only transformation that we're going to make from our base function of y equals 3 to the x. Okay, so how about number 2 here? G of x equals 3 to the x plus 2. This time the plus 2 is down with the 3 instead of up with the x. Okay, so again, our base function here, if you took away all of the things that cause transformations, we would be left with y equals 3 to the x, which is the same increasing exponential function. But now, which transformations do we have here? Well, we have the plus 2 again, but it's in a different place. What does this plus 2 do? That's it. It's going to shift us up vertically 2 units. Because this time it's down adding to y instead of up here adding to x. That's the difference. And just to make a note here, when you shift this thing up 2 units, that means your horizontal asymptote is also going to go with it, which means, oh, sorry, I wrote that wrong, which means your horizontal asymptote is also going to go up 2 units to the line y equals 2 instead of y equals 0. I just want to make a note of that because it's something that's easy to forget about. All right, number 3. H of x equals negative 3 to the x minus 1. Okay, so what's our base function? If we take away everything that creates a transformation, again, y equals 3 to the x is our base function, so it's the same increasing exponential. What transformations would we have to do to that function to get the graph of this guy? Well, we have a negative here and a -1 here. Let's see. The -1 here, that is going to shift us down 1. And what is this negative out front going to do? It's going to flip us upside down. We're going to reflect, um, I'll just say across the x-axis. It's going to flip us upside down. And it wants us to list the transformations in order. So if we have to reflect upside down and move this thing down 1, which one are we going to do first? So shifting up and down has to be the last thing that we do. So that means that we are going to have to do our reflection. We'll flip upside down, across that x-axis first. And then the second thing that we'll do is then shift this thing down 1 unit. Those are our transformations. All right, last one, number 4. K of x equals 2 minus 3 to the x power. So this looks a little different because up here we wrote this as plus or minus b to the x minus h plus k. Any addition that was happening to our b to the x happened on the right. But this time, there's the number out front here. I'm just going to rewrite this so that my brain can process this a little better so it looks exactly like what we were dealing with before. This negative is attached to the 3 to the x. So if I put my exponential function first, this is the same as negative 3 to the x plus 2. Because the 2 is positive, the 3 to the x is negative. So 2 minus 3 to the x is the same as negative 3 to the x plus 2. When I write it like this, it's a little easier to apply our transformations when they're written in this format up here. All right, so again, our base function is y equals 3 to the x. And our transformations here, the plus 2 on the outside is going to shift us up 2 units. And that negative out here is going to flip us upside down. The order that we have to do these things in is flip upside down across the x-axis. And the second thing that we'll do then is shift this thing up 2 units. All right. Last thing is that we want to graph this function. -3 x plus -3 to the x plus 4 power minus 2. Okay, so our base function here is y equals 3 to the x. If you remove anything that makes a transformation, so if I remove this and this and this, those all create transformations. 3 to the x is what I have left. So that's why my base is y equals 3 to the x power. Okay, so that's my base function. So I got to figure out what that looks like. So to make sure I know what that looks like, I'm just going to pick a couple of points. So I'm just going to do -1, 0, and 1. So if x is -1, y is 3 to the -1 power. That has to move downstairs. So I've got 1 over 3 to the first power. That's 1/3. If x is 0, then my y value is 3 to the 0 power, which is 1. And if x equals 1, my y value is 3 to the first power, which is 3. So I've got -1, 1/3. I've got 0, 1, and I've got 1, 3. Again, I'm just eyeballing this. It doesn't have to be perfect. I'm just going to put those points in to get a shape of this graph and to have a few points to move around. Okay, what transformations do we need to do here? Well, so we are going to have a negative here. We've got this +4 here, and we've got a -2 here. The negative out front, that's going to flip us upside down. This +4 up here with x, that is going to shift us left 4 units. And this -2 outside over here, that's going to shift us down 2 units. All right, so what we're going to do first, I'll switch to green. The first thing that we're going to do is shift left and right. So we're going to go left 4 first. So I'm going to take these two main points that we have, the 0, 1, and the 1, 3. Those are the easiest to move around. Those are the 2 points I'm going to use to kind of shape my graph here. So I'm going to shift them both to the left. 1, 2, 3. 1, 2, 3. And so if I shift this thing to the left, notice my asymptote doesn't change. If I shift y equals 0 to the left, it still stays y equals 0. So I don't have to do anything with that. So that's the first change that we have to make here. The second thing that we have to do after we go left 4, the next thing we do, flip this thing upside down. So I'm going to go from the point -3, 1 to -3, -1. I'm taking this point and I'm shifting it upside down across the x-axis. And I have a point at -2, 3. That's going to shift down to -2, -3. And then this is going to flip upside down. So my function is going to look like this, upside down. Okay, so now I've shifted this thing upside down. And so what do I have left to do? I just need to move this thing down 2 units. So everything here is going to go down 2 units. Oh, sorry, I'm trying to figure out how to draw this. It's hard to do that. Okay, and so when I shift this thing down 2 units, it looks like this. And notice that our horizontal asymptote is going to move with that shift down, and it's going to move down to y equals -2 is my new horizontal asymptote. So then I'll put a nicer graph here on this clean one for my final answer. I had, let's see, -3, -3. And -2. These were my points that I ended up with here. And that's where it's went. Okay, there is my final graph of -3 to the x plus 4 minus 2. Alex is probably going to have you identify a couple of points and then change them. I like to do the transformation. So you can do my way or Alex's way, whatever works better for you. Um, you can, hopefully that helps you figure out how to graph exponentials. Have a lovely day, and I will see you next time.